Hi everyone, myself Muthuramu, working as Assistant Professor, Department of Civil Engineering and PSN College of Engineering and Technology. In this lecture, we discuss about fundamental of structural analysis. So before going that, we know the what is structure, what is analysis. After that, we have discussed one by one. First of all, we discuss about what is structure. In general term, the structure refers to the arrangement of any relation between the part or elements of something complex. It is nothing but, for example, in our body we have the muscles and nerves. So we can connecting between the we have arranged the body to resist the load to the ground. So it happen to resist our load to the ground surfaces. So we can assemble the each and every part. So we can able to withstand the load. So that is in general term we denoted the structures. In civil engineering, a structure is a constructed system designed to the support load. We can construct the any building or any structures, whatever it is. If the load acting on the structure, the structure we can resist the or to apply to the load, the structure will be resist the load. So we can able to resist, we can analyze the structure. So that can be used to the building will be safe or unsafe. You have to design it. So the general term we design as a structure for the civil engineering purposes, in engineering purposes. For example, here the Eiffel Tower, dam, buildings, etc. So we can call it as a structure. Then second one, analysis. What is analysis? Before going that, we know the determining the effect of load, like the load which is denoted as like most of the loads like point load, uniform distributed load, uniform varying load. The depending upon the structures, the load will be carried out. But in structure, general the structure, the load acting under the dead load, live load, dead load, live load, snow load and wind load. These are the loads acting on the structures. It can be find out the forces at the moment, etc. In physical structure such as the building, bridges, machines or even biological structure, the goal is to be ensure that structure can safely withstand applied the force without excessive deformation of the or failures. So we can able to find the structure will be resist the load. We can apply the load, the structure will be resisted. That can be used to find the whether the structure is stable or unstable, or if any deformations will be created on the structures, that will be calculated for the structure will be safe or unsafe. It can be used to find this deformation of the structures. So here some loads acting on the structures. I will show the pictures. Here the dead load, snow load, wind load and dead load, live load. So these are the load acting on the structures. Here the dead load is without any moving load or moving objects, so that is called as the dead load, like a roof or whatever it is. The snow load means it is the load acting on the structures, like wind load. We know the wind load and snow loads. In dead load means like roof or floor whatever, so we call it as a dead load. Like live load means here the arrowhead denotes the pictures or people or furniture. So these are the live load. It is called as the moving load. So we can denote it as a live load. Then another one is hydrostatic and soil pressures. It is the underground of the movement of the load acting on the structure. So it will be produce any load on the or affect the structures. Here also the water load, if affecting the downward directions or upward directions or inclined forces acting on the structure, though it will be the structure will be predict the forces, how much of structures acting on the body for the following loads. Then second one, the types of forces. Here some type of forces I will show the structures. These are the main forces of that can be structures will be occurred. So first one is the tension. If the force applying one directions, the force upload on the opposite directions, so that is called as a compression. If they consider the object, the force will be the outward directions, out of the points, so that is called as a tension force. Here compression force, if you are applying the force inward the object, so that is called as a compressive force. Here the shear forces is it is the cutting force, here the one picture is shown. Then bending force, if you are load applying on the building, the load or the beam will be deflected or any deformations created, so that is called as the bending force or bending moment. If you moment create will be the corner of the points, the moment will be created if the based on the structures. Here the centrifugal force, the outer of the outer force of the field, so we can call it as the centrifugal force. Here the torsion will be the created twisted moment created, so that is so these are the forces of the structures. So mainly the structural analysis mainly focus on the first we have to determine the forces, like the internal forces, that is axial force, shear force and bending moment. After that we calculate the stresses and strain of the particular material. If you are applying the forces, that is if you are only the force acting on the structure, that is internal forces only acting on the structure, that is called as a internal force or static structures. We say the static structure. If you are applying the force to the particular structures, the structure will be deformations or deflections or any crack formations will be created, so based on the materials, so we can calculate the stress and strain in a particular materials. Then if you are applying the load, the deflections will and the stability to be calculated. It is to prevent the collapse, to avoid the collapse of the particular structure. Then it is ensure the safety and efficiency, so it is maximum optimize the material uses that can be used for any materials. So if you are opting overload, so we can predict the forces, so it is easily we can find the efficiency and safety of the structures. It is mainly used for the optimizing materials, because overloading or whatever it will be created on the structures. So these are the one is structural systems. So structure is classified into the two types. One is determinate structures and another one is indeterminate structures. Before that we going to discuss about the determinate and indeterminate. We know the basic equilibrium conditions. So what is equilibrium conditions? Is nothing but if the only the force acting, internal force acting on the structure, there is no reactions will be created, so that is called as the static equilibrium or equilibrium conditions. For example, the lying on the books on the table, so whatever, so if there is no external forces, so that is called as the equilibrium of conditions. So here the static equilibrium, a system of particles in a static equilibrium when all the particles of the systems are at rest and the total force on each particle is permanently zero. If you are applying the load, so we can find the equations. So it is expressed in the three equations, like summation of h is equal to 0, summation of v is equal to 0 and summation of m is equal to 0. So that is called as a here the summation h means sum of the horizontal forces and sum of the vertical forces and sum of the moments. So if the equation satisfy this equation, so we call it as a static equilibrium. There is no external force consideration, it is only considered for the internal forces, though the internal forces will be permanently zero, so we can call it as a static equilibrium. Then another one is determinate structures. In determinate structure means if the same the equations satisfy the equilibrium of equations only, so we can determine the determinate structures, a member or structure that can be analyzed under the reactions and forces determined from the equation of equilibrium. You can find the any reactions or any moment of the particular structure. The structure we satisfy these three equations, like summation of h is equal to 0, summation of v is equal to 0, summation of m is equal to 0. If that is not equal to 0 means that is called as a indeterminate structures. We need the additional equations or additional compatibility equations which will be occurred or created, so we can call it as a indeterminate structure. In determinate structure, summation h is equal to 0, summation v is equal to 0, summation m is equal to 0, so that is called as a determinate structure. In indeterminate structures, that is not equal to 0, that is the force will not be 0, so it will be considered for the another one equation. That equation known as a compatibility equations or redundant force, so we call it as a compatibility equations. So these are the types of supports. Here first one represent as a fixed support, and second one represents a pin support, and the third one represented as a roller support. Here fixed support is one end is fixed and another end is free. If you are applying the load to the particular column beam, the fixed support represented as a column, considered as a column. Here this line called as a considered as a beam. If you are applying the load to the structure, so it will be created for the opposite reactions as well as the horizontal reactions, because the fixed support having the here the translations will be created because the end is fixed, so there is no rotations. So here we are created the translation. So here the three reactions will be created. For fixed supported, we create the three reactions: horizontal reaction, vertical reaction, one additional moment, because the support is one end is fixed. So we calculate the three reactions of the support. And second one is pin support or hinged support. So here the it will be created the two reactions, one is horizontal reactions and another one is vertical reactions. If you are applying the load to the structures, it will be created the opposite directions. So it is a pin support or hinged support. And third one is roller support. If the load applying to the particular object or particular subject, particular structure, the load will be translate to the one directions only. The structure will be moving, the support will be moving on the horizontal directions. So if you are applying the load, it will be create the opposite directions. So only we calculate the only one reactions, it is vertical reactions. So what is determinacy? Determinacy is nothing but if we are calculating the internal forces and reactions. So how many reactions are we can calculate it for the given problem or whatever it is. By solving, we can use the equations, that is called as a determinacy. Is nothing but we can solve this like r is equal to 3n or greater than 3n, that is statically determinate structure, that is statically indeterminate structure. Here are denoted as a number of reactions. Here n is represented as the n number of members acting on the particular structures or number of joints. So joints we can call it as a denoted as a we call it as a j. Let us use it as a j. If the r is equal to 3n means it is called as a statically determinate structure. If more than 3 means we called as a statically indeterminate structure. So we called the additional equations will be needed. So we can call it as a statically indeterminate structure. If we need the 3 equations like equilibrium equations only, we have to solve by using the equation of equilibrium. So it is called as a statically determinate structure. If you need the additional equations or additional member, you have to find the any reactions. So that is called as a statically indeterminate structures. Here for this structures we have to analyze the, for example here I will show the some pictures for the building structures like steel structures. It is the analysis of pin jointed truss by the tension coefficient method. So we have to solve this problem. Before that before going to, we know that the following 3 steps. So after that you have to solve the problems, then only we can solve the problems. The tension coefficient method is a systematic approach to analyze the pin jointed truss structures. It is used for the through 3D structures or 2D structures. We can able to find the 3D structure and also 2D structures. It involves, we can consider this following 3 terms. First one is assigning the coordinates, and second one is expressing the equilibrium in terms of tension coefficient, force it is denoted as a length, and solving the linear equations. Here the linear equation denoted as the equation of equilibriums. First we can assigning the coordinates. How to assigning the coordinates? Before that after that I explain the one problem I will show there. Then that problem will show the how to assigning the coordinates and how the equilibrium of equations we can incorporate to the particular structures. So here I am described some application of stresses in engineering. The stresses mainly used for the bridges, roof systems, towers and most aircraft and aerospace, industrial structure and scaffolding. So these are the main applications of the engineering application of the stresses. Here the bridges means we can use the for the road work or railway roads. So we can use it for the bridges. Like roof system means you got that high rise buildings we can use it for the roof system. Then towers and mass used for the maximum load acting on the structure, so we can able to calculate the wind load calculations, and also aircraft and aerospace field in the industrial structures also, and also scaffolding. So these are the application of stresses in engineering field. So these are the sample pictures for I will show that the application of stresses in engineering. So we get the road structures and whatever it is we can use it to able to get the railroad structures or normal structures. So these are the structures for the example of the structures in engineering field. So here one problem we can solve the problem by using the method of coefficient, tension coefficient method. Here the one end is fixed on the hinged support and another end is fixed on the roller support, and also we can give the load to the particular point E, F and A and D. So these are the picture for the structures. So picture for the this is for the one of the truss. Okay, so we can able to find the here what is ask the problem, find the member force. Like find the member means what are the members, what is members. Member means connecting the points between two. Here A to B connecting the line, that is called as one of the member. Then B to C connecting the joints, connecting the points, so here called as a BC is one of the members, and C to D connecting the members, so it is one of the members. Then D to E, then C to F, then C to F, then F to B and A to F. So these are the members. What are the load what are the forces acting on the structures means like 6 kilonewton and 10 kilonewton and 12 kilonewton. So these are the forces acting on the structures. Then here the one end is supported on a pinged support and another end is supported on a roller support. So in pinged support we know that it will be created the two reactions. One is vertical reaction and another one is horizontal reactions. In vertical here the roller support will be provided, so only one directions, so for the vertical directions, and also the distance will be given, horizontal distance will be given, and also the vertical distance also will be given. First our aim is to find the to satisfy the equilibrium conditions. So find the reactions. So what are the reactions for A? What are the reactions means like VA, HA and VD. So these are the reactions. So we denoted as a vertical reaction as point A, H denoted as a horizontal forces acting on the particular point A. Here VD means here only one reaction because it is supported on a roller support, so we can consider only for the vertical directions. So first we can able to find the apply the equation of equilibrium condition. What is equilibrium equation condition? What are the equations for equilibrium? Like summation H is equal to 0, summation V is equal to 0 and summation M is equal to 0. First of all we find the summation H is equal to 0 if we are consider the horizontal forces only. So summation H is equal to 0. First we find the sum of the horizontal forces. So number of horizontal forces for this picture, there is two horizontal pictures available only for that pictures. Here 10 kilonewton one of the horizontal forces and HA also one of the horizontal forces. If the force acting left to right direction means it is called as a positive. Then the force right to left acting, it is called as a negative directions. So first we apply the summation H is equal to 0. So here A, from the A point only one horizontal forces, so it is act as a negative direction because the force acting left to right directions, right to left directions, so we consider as a negative direction. So minus HA plus here is plus 10 is horizontal directions. Here why you are putting a plus means if the force acting left to right direction means it is called that means the force acting inner of the materials, so it is positive. If the force acting outer of the material is the negative, the simply we consider as the force acting inward and outward. Here the HA act as a outward directions, here the 10 kilonewton act as a inward directions, so we consider as a plus point, so which is equal to 0. So here HA is equal to 0 from the equation that 10 kilonewton is goes on the right side of the equation, so here minus, the minus cancel, so H is equal to 10 kilonewton. Now we apply the summation B is equal to 0, sum of the vertical force is equal to 0. Here one vertical force is VA, it is upward directions. If the force acting upward direction positive, if the force direction acting downward direction means it is called as a negative directions. So here VA is upward direction, so VA, here VD also upward direction, so we take the value as plus. Then 16 kilonewton one of the vertical forces, 12 kilonewton one of the vertical forces. The both the forces acting on the member, acting on the trusses, it is downward direction, so we take as a minus, so minus 16 minus 12 is equal to 0. So we call it as the, so we find from the equations we find the VD. Before that we find the taking moment about point D, taking moment about point A. So first we, from the moment about point A, we can able to find the so we can find the VA. So if the VA means, if you are consider the point D, here D, take a moment about point D, here only one vertical direction, here there is no distance because this is our origin point. So V into VD into D, VD into 0, because 0 means in general moment is equal to M is equal to force into perpendicular distance, force into perpendicular distance. So here F means force. What is the force? The VD is a force. Then perpendicular distance means the point between the distance. Here there is no distance, so we are putting V into D 0. So it is not considered in our account. Next, if the 12 kilonewton acting on the downward direction based on the point like BD means, if the force it is the anti-clockwise directions, like if the force acting this like it is positive, if the force acting anti-clockwise it is called as a negative directions, so it is called as a negative direction. If the 12 kilonewton force acting on the anti-clockwise direction, so that is here put minus into the distance between the C and D, here 5 meter. So here the distance between the 12 into 5, so this force will be calculated. Next one is 16. The 16 force will force acting on the support, it will be the same negative direction because it is anti-clockwise direction. So we can put the distance from the minus 16. Then D to B point, the totally 10 meter, here 5 to 5, here 10 meter. So we denote, so multiply the distance 10. Then plus 10 into 4, here the one of the horizontal forces will be taken, it is the clockwise directions, so this is plus, so 10 into 4, that means the distance will be half of the that means the vertical distance. Here the vertical distance is 4, here the vertical distance is 4, here and one vertical force is VA. So VA is also clockwise directions about the point D. VA also called as a positive direction. So here the total distance, here 5, here 5, here 5, so total 15. So 15 into VA. From the equations we get the VA value. In this VA value we can able to substitute here vertical force, so we can find the VD distance, that means vertical of the point, vertical reaction of the point D and vertical reaction of the point A and moment. So we from the moment we can solve the we can get the value from the VA and VD and HA. So we can find the, we can able to find the 3 reactions. And next one we can find the coordinates here, the A point. So this is A point, consider the A points. So here put the value for 12 kilonewton, 10 newton and 16 newton from the the value already we are find it from the reactions. So next we find the set the coordinates. Here the first point is A, it is the A as a consider as a origin, so we provide the 0, 0. So here x directions will be 0 and also y directions will be also 0, so we call it as a 0, 0. Then next come to the point B. Here A to B, like the x directions, this is y directions, this is x directions. So 5 means x directions, 0 means y directions. Here A to B 5, but here there is no distance is given, so we call it as take the value of 0. Then come to point Z, the total distance 5 plus 5 10, the vertical distance is no, so we consider as a 0. Then come to the point D, here the total distance 5 plus 5, here the total 15, there is no vertical distance, so we consider as a 0. So we find we can able to find the A coordinates, B coordinates, C coordinates and 15 D coordinates. After that we will find the E coordinates. How to find the E coordinates? Here the distance will be, here the point will be E. If the distance, total distance here 5, here also 5, so totally 10, because if the force acting this point only, so that take this distance from A to C though, so totally distance is 10. Here the D to E, the total distance mentioned at the 4 meter, so 10 comma 4. Now consider the point F. So point F means here the x distance is 5, here the s distance is 5, so provide here 5. Then BD distance is, that is 4 meter, so we provide the 4 meter. So this is the method for we calculate find the coordinates. This coordinator which helps to find the member of the support. First of all we consider the joint D. This is our joint D. Here this is point D. If the member connecting to the C point one member and the D point the connected to the member as a E point, and one vertical forces will be acting on the structures. So this is for D joint. This is for our D joint free body diagram. Here one vertical force. So this is for coordinates, D coordinates. This is for C coordinate. This is for E coordinates. From this point we can able to find the reactions of the tension of the coefficient of the particular member. So consider first we take the value of summation V is equal to 0. Summation V is equal to 0, which means here one vertical force 60 Newton. If the D to E, if the point acting on the structure, it is inclined force. So we don't know the consider the what is directly we don't know the take the point it is vertical or horizontal. So this inclined force which is converted into two components like x component and another one is y component. This is x and this is y component. So from this here put the y. What does mean y means? That is y distance, because we find the value of vertical distance, so we are putting the y distance. Here D means the point, that means the joint member DE. So we can take the value of DE into T represent as a tension coefficient. The T represent as a tension coefficient at the point DE. Here the 16 means the vertical direction is load the acting on the joint D, it is a vertical direction, so positive. So summation of V is equal to 0, sum of the vertical forces. Here one vertical forces, that is means VD. So Y into DE into TDE plus, that means here the force acting on the upward directions. So I will consider further this is the positive directions. So here the 16 also vertical direction, so we take the positive direction which is equal to 0. Here next how to write the 4, that is here the consider the coordinates. So we can consider the coordinates D coordinates and E coordinates. Now we consider for the only vertical directions. So here 0, here 4. So we subtract the value, that means 4 minus 0 which comes out the 4 into it is the unknown. So put the unknown force TDE plus 16. So from the equations we get the TDE. So we get the value of TDE, it is known as a kilonewton per meter. Similarly, we can able to find the summation of H is equal to 0. So sum of the horizontal forces, here one horizontal forces and that means CD one of the horizontal forces and also DE one of the horizontal forces. The both are the negative directions. So here the show that the conversion sign conversion. If the force upward acting on the upward direction positive, the force acting downward direction is negative. If the force acting from the origin of point right side is positive, if the force acting on the left side, so it is denoted as a negative directions. So here if the force that these two forces acting on the origin from the origin of the point left side, so we denoted as a minus minus. Here x denoted as the distance, we consider as a x we consider as a only for horizontal distance, so we denoted as a x. So these are the points like DE and CD. I'm already told that what is T, that means tension coefficient of the particular point. So here consider the coordinates DE. Here the D 15, here the E point is 10, so 15 minus 10, which comes out the 5. Then DE, so we already find the TE value, so you can substitute the value directly, minus 4. Here the same distance CD from the picture, C, consider the point T, consider the point C. So we can only consider point the x directions. Here 15, here 10. So 15 minus 10, so which comes out to the 5. So with this for unknown force, so we can able to find the TCD value, which comes out to the 4 kilonewton per meter. Next, consider the joint E. So this is our point joint E. If the load acting vertical direction is downward direction, so this is here the F point, it is one of the D point, it is one of the C point. The joint taken comes out from the main picture of the diagram. So the same calculations part will be considered if the upward direction positive or negative direction is negative, or this is positive or this is negative. First you find the summation V is equal to 0. Summation how many horizontal forces and how many vertical forces for the joint D. Here 2 vertical forces and 2 horizontal forces. Here 1 vertical forces, here also 1 vertical forces. So if the force acting downward directions, so put minus. So if you are consider the vertical force means put y, then you take the point CE, so EC or EC or CE, whatever it is. So next we find the tension coefficient of a particular point. If we consider a point ED, it is also the negative directions, so put the negative sign and YDE and TDE. So this is also 12 kilonewton if the force acting downward direction, so we put the minus direction, which is equal to 0. So here consider the coordinates from E and C. Here 4, here 0. So 0 minus 4, that means 4. So here the sign already will be comes out to the previous. So minus into TCE. The same DE. Here is 0, here is 4. That means 4 minus 0, 4. Into, we know the value of DE. So put the value T is equal to minus 4, minus 12, which comes out, we get the value of TCE, 4 by 4, which is equal to 1 kilonewton per meter. Next we solve the summation H is equal to 0. Like summation H is equal to sum of the horizontal forces. We can able to find all the horizontal forces. In this picture, the only horizontal forces for E to F, one of the horizontal forces, and also here also one of the horizontal forces like E to D or D to E. First we consider the point E and the point F. So here the negative directions. If the force acting from the origin of the force acting on the left side, so we call it as the negative. Here x denoted as a horizontal directions. We consider the point EF and TEF plus. In this picture, this is the positive because the force acting on the from the origin of the point, the outer of the points. So the force acting on the inside of the structures, so we called as a XDE, like plus. Here put the plus directions into DE. So here consider the coordinates EF. Here 10, the point here 5. So 10 minus 5, here the 5 value. The same, this is for our unknown force, plus X DE. Here DE means here the 15, here 10. So 15 minus 10, which comes out to the 5. We know the DE value, already we have to find the DE value minus 4. So put the value minus 4, which will get the value from TEF is equal to minus 4 kilonewton per meter. Next we consider the point C. From the picture we consider the point C. So this is for our joint C figure. So this is our point C figure. So here mention the coordinates, E coordinates, D coordinates, E coordinate, F coordinates and B coordinates, and also we mention the direction of the forces. So first we consider as a summation B. Before that this value taken from the before the joints, like from the joint D and C, this value taken from the point C and D. So first we consider the summation B is equal to 0. Here number of horizontal forces acting on the number of vertical forces acting on the body, this is one of the vertical forces. Here also one of the vertical forces, because the force is acting on the inclined directions. So we split it into two components. This is X component, this is Y component. So here the two vertical forces and two horizontal forces. Three horizontal forces. First we consider the summation V is equal to 0. So summation V is equal to 0 means first we consider the point CE. So YCE into TCE plus here the same point CF. So we consider the point CF into CF. So first we consider the coordinate CE. Here the y coordinate is 0, here the y coordinate is 4. So 4 minus 0, 4, which is the TCE value we already find it from the previous joint. So take it into account 1 plus YCF. Here YCF we consider the YCF, that means CF coordinates. Here C, this is the F coordinates. We consider for the vertical directions, here 0, here 4. So 4 minus 0, which comes out to the 4. This is our aim is to find the CF coordinates. So to take the CF value is equal to 4 by 4, here minus 1. So we get the minus 1 kilonewton per meter. Next come to the summation of V is equal to 0. Sum of the vertical forces. In this picture we know that the three horizontal forces. One is C and D, one of the horizontal forces, and C and B, one of the horizontal forces, and C and F, one of the horizontal forces. First we consider the CF. This is for negative direction, the origin of the points acting on the left side. So we consider as a negative sign. So here put the negative sign XCF and TCF, and also the joint for the joint C and F also negative direction. So we put the minus directions and TBC, plus here the XCD is positive. So here the positive directions. So we consider as a positive. Now take the coordinates from the point C and F. Here C 10, here F means 5. So take the value from the subtract the value 10 minus 5, which is comes out to the 5. We know the value of TCF from the before joint TCF. Take the value is 1 minus BC, like here the minus same. Here consider the coordinates BC. Here the 10, here is 5. So 10 minus 5, which comes out to the 5 into TC DBC, plus the here consider the joint CD. Here the 10, here the 15. So 15 minus 10, which comes out to the 5 into CD. We know the value of CD, which is comes out to the 4. So substitute this value, we get the DBC value, which is comes out to 5 kilonewton per meter. Next we consider the take the joint B from the picture. This is here the figure represent as the one horizontal forces and two vertical forces and two horizontal forces. First we find the vertical reaction, because there is only one unknowns, it is easy to find the vertical forces. Here the only one unknown forces, that means BF. So YBF, so is it positive directions? So here the positive direction, so put the plus point here. So YBF into TBF. Now consider the coordinates B and F. Here what is B coordinates? Here 0, here 4. That means 4 minus 0, which comes out to the 4, into TF is equal to 0. What is the TF value? If the 4 comes out to the left side, sorry, right side, 0 into any term into 0. So we called as a TF is equal to 0. Now we consider as a summation H is equal to 0. There is two horizontal forces. One is BC and another one is BA. So first we consider as a negative directions like BA. It is the negative sign. So here put the minus XAB into TAB plus come to the point BC. This is the positive. So we put the value of here the positive sign XBC and DBC is equal to 0. Here we consider the point AB. So we take the value is X. Here is X, here is 0. So 5 minus 0, which comes out to the 5 into TAB plus XBC. Here the 5 value, here the 10 value. So subtract these two values. 10 minus 5, which comes out to the 5. We know that the value of BC. So from the previous joint, we found the value of BC. So put it the value here. So 5 into 5 is equal to 0. So TAB is equal to, from this equation we can able to find the TAB, which comes out to the 5 kilonewton per meter. Next, consider the joint A. From the picture we can take the joint A. Here A joint we know that the already two reactions. One is vertical reaction and another one is horizontal reaction. Here the B support is connected. Here B supported is connected. So here the two horizontal and one verticals. So because we only for taking the value of summation B, because the remaining values find out the AB coordinates and AF coordinates from the equations we have already find it. So only we consider for the BF. So we consider it is considered for the only one directions. So we take the it is positive. So YAF into TF plus 12. This is for the positive sign. So put the value is plus 12, which is equal to 0. So which is comes out the AF. AF means here is 4, here is 0. So 4 minus 0, which is comes out to the 4 into TF plus 12 is equal to 0. From these equations we get the TAF, which is comes out to the 3 kilonewton per meter. Next, it is so before slides we have find the all the tension members from the point A, from the point A, point F and point E and point C. So using these joints we can able to find the tension of the coefficients for the particular joints. Next we consider find the length of the members. What are the length of the members? Like here, I show that here consider the member A to B. Here consider the member A to B 5 meter. Here consider the member B to C 5 meter. Here consider the member C to D 5 meter. So all things are equal. So I put here AB, BC, CD and EF, which is equal to 5 meter. Then next we find the CF value. Next we find the CF value. Here the CF value means this is for BF is equal to 4 meter and CF is equal to 4 meter. So we don't know the value of AF and CF. So find these two length. So we have to, our aim is to find the AF length and CF length. By using Pythagoras theorem we can able to find these values. So here AF, CD and FC, which is equal to root of opposite side by adjacent side. So we know the two values. So here the root of pi squared plus 4 squared, which comes out to the 6.4 meter. So we get the all the members of the length of the members. So it will be help to find the length of the members. Then form here one tabulation. So like this is our member AB, BC, CD, DE, CE, CF, BF and EF and AF. So 9 members, because from the figures we can able to see the members list. So A, B, one of the member, then B to C, one of the member, then C to D, one of the member, then D to E, one of the member, then C to E, one of the member, then C to F, one of the member, then B to F, one of the member, then E to F, one of the member, then A to F, one of the member. So here around 9 members are there. So we can able to find the 9 members as well as the tension coefficient. Next we put the value of tension coefficient. We already find the AB coefficient, BC coefficient, CD coefficient, DE, CE, CF, BF, EF and AF. So all things we have already find the coordinates. Then length of the member, we know that the AB of length of the member AB, so 5, 5, 5, here DE means 6.4 and CF means 6.4 and EF and AF is equal to 6.4. What is the force? How to calculate the forces is nothing but force is equal to nothing but tension coefficient into length of the coefficient, which is equal to force. That means force. How to calculate the force? Force is equal to tension coefficient into length of the member. That means multiple this two value, here 5, here 5, so which comes out to the 25. Same here 5, here 5, which comes out to the 25. Here 4 into 5, which comes out to the 20. Here minus 4, here 6.4, which is multiplied by the 25.6. Here 1, here 4, 1 into 4, 4, minus 1 into 6.4, which is comes out in minus 6.4. Here 0, so 0 into any term 0, minus 4 into 5, which comes out to the 20, that means minus, here minus 3, here 6.4, which comes out to the 19.6. Here we denoted as the nature of the forces. What is the nature of the forces? Means here tension or compression, which force acting on the structure, which force can be acting outward of the structures. So we can able to find the nature of the tension. Here is the positive, so we denote as the tension. Here also tension, here also tension. Here is compression, because here the minus directions, if the force directions are the inward direction, so we call it as a compression force. Here is a tension, here is compression, because here the minus, here there is no forces, so we consider as a 0. Here the compression, because here minus, here also compression, because here the minus directions. After that you conclude this problem, we can able to find the tension coefficient. We can find the member force by using the tension coefficient. If there is lot of methods are available for the structural analysis to find the member reaction, like system, like tension coefficient method and kinematic indeterminate structures and the stiffness matrix method, finite element method, influence line diagram. So these are the methods you got to find the member of the particular structures. So next, after that, complete this tabulation, we have to mark the diagram. If all the values comes out to the mark here, the value of 12 and 10, if the from the value taken from the, we can find the VA and HA. Here the 10 denoted as a HA. Then we can find the value of the 16, which is equal to VD, which is called as a VD value. Next, substitute the members. Here the member is AB, the force acting on the 25 kilonewton. So here to here 25 kilonewton. Next, the member is BC, the same also 25. So this is 25. If next consider the member CD, so here the 20 kilonewton. So you draw the 20 kilonewton. Next we consider the member DE. If the point is 25.6, so we consider as a 25.6. Next we consider the point CE. So this is CE. If the load acting on the member like 4 Newton, then consider the member CF. Here the consider the member CF. Here the 6.4 kilonewton. Next BF is 0, so there is no forces acting on the particular joints. Next take the member EF. Like this is for EF. If the member acting on the 20 kilonewton. Next take the member AF. Here the member is for 19.20. So this is for compression member. So here if your reaction means it is represented as a R, if the M means like the members, if the J means that is called as a J means that is called as a joints. So what are, how many joints there? Here one of the joint is there, here one joint, here the B point is getting the one joint, here the C point is getting the one joint, and D point is getting the one joint, and F point is getting the one joint, and F joint is getting the one joint. So here 1, 2, 3, 4, 5, 6. So totally 6 joints we have to find the joints. If you are using the any relations, you have to find the if the structure is, whether the structure is determinant or indeterminate structures by using the equations. So this is one methods we can find the member forces of the particular truss. The same method also applicable for the any kind of trusses or any kind of load acting on the particular structure. If the load acting on the point load is here, the point load is given, or here the vertical load is given, so whatever it is, so we can easily able to find the coefficient of member. This is the method for we can find the members for the joints. So this is for the one of the joints. So once again I am repeat it. So this is the method we can find the, so assembling the coordinates. So like the A point, B point, C point and D point, how many joints is given there, so we can able to take the value of coordinates. Next, the expressing the equilibrium condition, like summation of H is equal to 0 and summation of V is equal to 0 and summation of M is equal to 0. So it is express the equilibrium conditions. Next, solving the linear equations, like find the member, how much of forces acting on the members. So which it is help to find the forces acting on the body. It is easily find the value. It is also used for the 3D trusses as well as the 2D structures. This method is applicable for the used for the 2D structure or 3D structures. So this is the procedure to find the members for the particular sections. So these are the, so almost we are complete the problem. So it is very easy to find the members. Okay. So these are the totally the term is a find the internal forces and the stress and the strain of the particular materials. So these the deflection and safety. So these three things are very important to design the structure, because if the n number of load acting on the structure can be resist or withstand the load, how much of load acting on the body. So the body will be react to the opposite directions or opposite the force. If the resisting the or equating the both forces, the structure will be neutral. If any one force is a higher level, the structure will be collapsed. So as an engineer, we consider this elements, we can able to solve the problems and construct the structures for the any structures. Here the any structure means here mentioned for the RCC structures, steel structures, whatever it is. So so we can aim is to find these considerations only. We have to define the structures stability. Then will be the structure will be stability. So otherwise the structure will not be able to resist the load. If the load here, okay, here the force, the load will be considered for the moment. So the moment is nothing but force into perpendicular distance, that will be considered for the pressure. It is so, it is the predetermining the effect of load, which is we consider this is one column, this is one beam. So if we are applying the load for 10 kilonewton, after the applying the load, the beam will be deflected like that. So we can able to predict the force, then only the structure will be can resist the load or we cannot resist the load, then only we can find the structure strength. it will be helps to avoid the any collisions or any failure of the structures. So that is the load. So it is called as a determining the effects of the load. The effect means if the load applied to the body, the what happen, the body will be move, the deformations or any crack formations or any bending movements will be created. So it is used to the find the effects of the load. It is the on the physical structures means like the building, bridges and the machines, or even a biological structures like the treatment plant will be, and also the building structure, bridges. So it can be calculate the n number of forces acting on the structure, so we can able to find the load calculation. Then only the structure will be the safe or unsafe. It is the economically the structure will be constructed. So it is ensure that all the structure can safely withstand the applied forces without any excessive deformation or failure. So this is for very important. So we can aim as an engineer ensure that all the structure can safe withstand. How to they are expecting, or how to they are ensure that whether the structure is withstand the applied force. So from the method, by using this method we can able to find the if the structure is applied the load, the structure can resist the load or not. So it is easily find out. So without any excessive deformation it will be create the failure. So the total structure will be created on the failure mode. So it is able to find the easy way on the way. So almost here I complete all the things for the one sample problem. It is easy to find the how to find the member. So first procedure we can once again repeat. If the first procedure we can calculate the reactions. If the figure is given, next you can calculate the reactions. How many reactions for the picture? Here 2 reactions, here is 1 reactions. That is because here the hinged support, here is vertical support, sorry, here roller support. So here 1 vertical directions, here 2 reactions. By using equilibrium equations we have to find the summation v value, summation h value. From the equation you can able to find the 3 reactions force. After that next we consider the find the coordinates. Here 0 0 5 0 10 0 15 0. So whatever is from the find the coordinates. Then take the joints for 1 by 1. We can able to find the tension coefficient of the particular joints. Then finally we conclude the members, find the force, how much of forces acting on the members. If the B member means the force acting at the 25, here 25. So the nature of forces will be also the calculated. So it is considered as a compression or tension. So it will be the structure will be the safe or unsafe, the engineer will be considered. Okay, thank you.